Alright, do a little video of welding, cast, let's do it. How I do it. What's So I've prepped this back surface. Normally with this machined all the way down, the surface is super wide compared to the flange. So what I've done is I've come around and tapered the outside of the extra casting so the toes of the weld are fairly even to each other. I like the toe. Not a must, but it does help with stresses quite a bit. I like the toe to be at the edge of the parts. Even, make sure our gate clears. Everything looks good. It's 308 filler rod. You can use whatever you want. But higher degree of stainless, the less good at it you need to be. Saying 0.8 pulses a second, 50% duty cycle on the pulse, 200 amps on the pedal. Low CFH for this part, just tacking and running quite a few stringers. The stringers are all going to be there to hold this part together while I spin it. On the rotary table. Now we could do this with a number 8, no problem. I like I have a 12 on it because that's what I'm going to run when I do the final. You can do this with the 8, you'll just get more reds and purples if your filling gas is good. Everything's a mess because it's been non-stop the last 2 weeks. So these turbos, there's one Hero that needs a 351 flange put on it, and there is 2 villains that need 351. Now I could have taken a 351 housing and changed it back to this first tack. Keep it kind of small because what will happen, usually when these things pull up and you clamp them back down, they can move. So if you run too wide of a tack on your first tack, what will happen, you won't be able to adjust this. Yeah, see, it's down towards me. Like these 2 clamps. At the other side, you're going to come back and reheat / run a little more weld on this side. So when we tack this side, it's going to put a lot of stress. Other side, if you don't go back over to it, there's a good chance that tack will pop when you're doing your other stringers. Not a huge deal, but say it pops and you don't got enough tacks in place, it'll lift it up and you have a gap. And if you have a gap on these, you don't have a heat sink that'll clamp to these, what will happen is it'll warp it. So the back of these flanges are surface ground, flat on belt sander, big one. There's no air gaps in here. So what that does is there's nowhere when this goes to shrink, there's nowhere for it to shrink to. It just increases the stress load on the part, which is acceptable because the weld can tolerate that and it'll keep the surface. And run your stringers small because we're going to be running over these stringers. Make sure at the very ends, especially with a lower grade stainless filler, you got to taper out fairly smoothly, or split right down the middle of the crater. First two parts, cross tack the other direction, and then tacks in between those, tacks in between those. And the tacks are all stringers. Part is my block. Front twos and some. Yes. Side note as well, you don't need a pulser. Once you have them without it, especially on machines that have lower duty cycles, come out about the same, just a little bit less width on your toes. So you do want to narrow up that joint. The pulse, because it's hitting at a real high amperage, pushes the puddle out wide. It doesn't put so much heat into the puddle that the puddle starts to get unstable. Your filler rod, dissolve. I got 3 of these to do. All the tacking first. Like so. These are the tacks. Then we're going to come in with a 3/32 or 1/8 inch filler rod with a lot more amperage and run this in one shot on the positioner. Flat surface, taper. That taper is just reducing where the toe lands. What that does is reduce how wide I have to make this. Remember, first one, just round towards me. Yep, same thing. Yep, that's all 3 tacked up. Next thing is going to be setting up the turntable. This is the heat sink. I do not have a clamp for 351s, nor do I have a heat sink for 351s, but a 4-inch V-band clamp for a 4-inch heat sink. Pretty good fit. So at least we can pull heat out a little bit to help with our aesthetic appearance and puddle stability as we get towards the end. So big thing to remember is that as the base material around the puddle gets hotter, the ability for the puddle to basically actively move heat into the part reduces. So the chill zone on the outside is chilling less, and that puddle will start to wander around more. So if you're ever getting like frustrated with something, if it's not arc flow, if you're welding a part and the puddle just will not stay in the same spot, more than likely it's because you're not patient enough. I know I certainly am not. And you need to wait for the part to cool down, especially like 065 and thinner wall stainless steels, especially like tubing. When that material gets hot and it does not take much, you will start to get a lot of puddle wander. So the arc will actually be stable, but the puddle itself will be shifting around quite a bit, ruining the aesthetic look of the weld, and that is because the part is too hot and the material is not pulling heat out of the toe edges of the puddle at a rate that's fast enough to keep the puddle stable as it moves forward. So basically, you think of it as puddle growth versus heat input versus the rate of heat being pulled out of that is incorrect. So, and when it's right, you're good. Like, so if you ever get the opportunity to weld in like really thick materials, you can basically bury the things with as much amperage as you want, and the puddle doesn't get too wide. Versus when parts get hotter, their ability to dissipate that heat off is reduced, and as they get hotter, it gets worse and worse. So the puddle starts to get all kinds of wishy-washy. And it's very frustrating, but that's what's happening. So on to spinning these things up. So a little trick when trying to center something up on turntables, I just use the arm, put the arm against it and spin it until the arm stays in the same spot. So that's where this is at. It's ready to go. I am terrible about writing down my speeds, so I'm going to fill that out. And then I'm going to run it. I have the duty cycle set lower than I normally do, just to try it out. Normally I run like 70. I think I have like 50. I want a little wider puddle when it hits. I don't want to carry that heat between bursts. Ground 23 CFH. Try and do the Jody at Weldmonger 1/8 inch a second thing. It's kind of a pretty good with thumb. And another trick is start on your tack. That's a nice mistake.
to take a break. Get my shoes.
Okay.
Crack me a beer right now. It's great they're in here. A lot of dead springs. They're out of those housings.
No, these are custom ones.
Oh, okay. There you go. Well, I'd be surprised if you're out already. It'd be a good thing, I guess.
It'd be bad because then I would have not ordered when I should have.
Good because they're all sold though. Not out the door.
I didn't like how it was carrying the puddle during the pulse off. So same amperage, should be same speed, but I turned the duty cycle from 60 to 70%. And sharpening my tungsten again because I'm an amateur. So the results of all of them afterwards. That carried my pulse off puddle perfect. What happens when the these cycles too low and the material is too cold or thick is the puddle will, I don't know, draw it, but it'll U-shape backwards towards the tungsten and lift out of the root in the center because the arc force is too low. It's the arc force temperature is too low, so not enough arc pressure and temperature in that zone, and you can't really sharpen the tungsten into different ways to get that out of there, and you're filling quite a big space. Oh shoot, I forgot to put the heat sink on. There we go. Well, we are still flat, and the color came out good, surprisingly. Put that on for the next one. But that's kind of what's going on. So I needed more like base amperage at the bottom to maintain enough arc force and arc temperature to keep driving home that root during the low end of the pulse. And then when it pulsed up is when you bring the filler rod in, and while that puddle's growing, you're bringing in filler to Not just, so the arc pressure and temperature jump is what drives the puddle out, and then the filler is what raises the puddle up. So if you don't have enough filler, it'll concave the weld joint, and it tends to not have the freeze line appearance you want. So that's how that works. So let's do the next one. That was fantastic. I don't know if you can see that. That came out stellar. And I know there's probably not too much difference, but you see how there's just kind of the beads kind of moving around a little bit compared to the one we just did? And that's the arc. Okay. That's no pulse. So you see with no pulse, the bead's significantly tighter. Probably should have had a 332 filler. Had 1/8 and 1/16. 1/16 actually worked really good. It just ran out. And I had a 1/8 sitting there. 1/8 was too big. It was freezing. First my temperature. 1/16 was probably pretty ideal. If I wanted to get like a bigger freeze line or carry the freeze lines a little farther apart, a 332 would have allowed me to do that. With the 1/16, you're feeding quite a bit faster and quite a bit more. So like reset time at the hand per position is quite a bit higher. Quite a bit more heat put in the part doing it this way. Flatten enough. Fine. We set on the surface grinder if we need to, but here it is. Up close to this one. We'll be putting in some photos, but see just how the bead's way tighter. And way narrower, way narrower. Nothing wrong with that. It's just a different look. Real fat look with the big ripple lines, you know. It sells. To be straightforward with you. Whether you like it or not, that's just kind of how it works. The aesthetically pleasing part of the weld is, a big part of automotive sales. You can, it's just what it is. So that's that. I'm going to go get some close-ups of these. Once they cool down, I gotta go modify some S300 compressor covers now. I need to change their Borg outlet to HX35. So that's the next thing I do. And then after that, I got to modify an HX35 to have an H1C non-intercooled hose outlet that's the same dimensions as the original one. So, told you, it just keeps on going. Careful what you get good at. You guys have a good day. Bye.